homework. Let's look at the first set first, the 1 through 16 that we did a lot of them in class, but then I had you finish them for homework. How about any of those that you need me to work? Yes. Number 10. So I have x to the 4th plus 3 equals 13 minus 9x to the 4th. So I need to get everything on the same side, right? Keeping my leading coefficient positive. So I'm going to move these to this side so that I add the 9x to the 4th. So I'm going to add 9x to the 4th and subtract 13. So I have 10x to the 4th minus 10 equals 0. Everybody good there? All right, do I have a GCF? Yes, what's the GCF? 10. So if I take out 10, I'm left with what? Minus 1. So now I have to decide, is this a special pattern? So I'll look at my orange sheet and go, okay, it has two terms, so if it's anything, it's either a difference of squares, a sum of cubes, or a difference of cubes. Is it one of those three? Difference of squares, that's exactly right. So to factor, I do, and keep that 10 following this down. The square root of the first, which is what? X squared. Square root of the second, that's right. And then x squared plus 1. Okay, so if it's something that if both of them multiply by themselves twice, it's squares. By themselves 3 times, it's cubes. So you just have to decide which one. And it might not be either one. And if it's neither one, then stop. Do you see any other pattern here? I can do the difference of 2 squares again. One is still a perfect square. So this one factors down again. So I have 10, and how does it factor? That's exact. The order doesn't matter there. This one does not break down. We don't have a sum of squares. We have a difference of squares, and we have a sum of cubes. We don't have a difference of, a sum of squares. So I leave it just like this. And now that it's factored correctly, or completely, I'm ready to set each piece equal to 0. Well, 10's never going to be 0, right? There's nothing you can plug in that's going to make 10 0, so you don't have to worry about that one. X minus 1 equals 0. X plus 1 equals 0. And x squared plus 1 equals 0. How many solutions should I get when I solve this? 4. I get x equals 1. X equals negative 1. Now I have to subtract this. Now what? That's exactly right. I square root both sides and I get plus or minus I. So there are my last 2 solutions. Yes. If it's not a pattern, keep it. And then you can get rid of it with the square root when you solve. What else? 6. So I have 8x to the 5th plus 5x squared equals 4 squared. What should I move? The 4. Why are you moving the 4? Keeping that leading coefficient positive, making one side equal 0. That's exactly right. So I have 8x to the 5th plus x squared equals 0. Any GCF? X squared. If I take that out, I'm left with, what is this pattern? Sum of cubes. Perfect cubes. That's exactly right. So this is where I have to get ready and do my little parenthesis, big parenthesis, same change plus. What goes in the first set of parentheses? 2x and 1 squared. That's exactly right. That's right. Solving this one's a little bit harder. I should get 5 solutions, right? X equals 0, but that's a repeated solution. That one happens twice, so that counts for 2. 2x plus 1 equals 0. And 4x squared minus 2x plus 1 equals 0. Subtract 1 and divide by 2. That's an easy one. What happens with that last one, though? That's right. The first one is multiplicity 2. But how about that last quadratic here? It's the quadratic formula. That's exactly right. It's not going to factor down for you. When you have sum or difference of 2 cubes, that trinomial is not going to factor down any further for you. So you might as well go ahead and get ready to do the quadratic formula. So opposite b, which is negative 2, so it's going to become positive 2, plus or minus the square root of b squared minus 4 times a times c all over 2a. Now I just have to simplify. 4 minus 16 is negative 12. And I'm going to come off to the side to do this negative 12 to show you what happens here. The first thing that happens is I have an I that comes out. And now I can break it down. How's it break down? 4 and 3. So it's the square root of 4 and the square root of 3. What's the square root of 4? 2. So this becomes 2i times the square root of 3. I feel like we did this one yesterday, did we not? I must have done it in third block. And because everything is divisible by 2, I can go ahead and divide that out. So it becomes 1 plus or minus I root 3 over 4. You can divide all of these by 2. So at this point, I would like you to be able to do this. I probably still won't take points off if you're here, but I will say simplify. But you're coming on a time where I will take points off soon. So start getting into the habit of simplifying like that. Yep. Same set? Next set? Yeah, let's go to the next set. And you said 11? And you finish with that? Okay. Number 11. 2x cubed minus 5x squared plus 40x minus 100. It already equals 0, so as I look on my orange sheet, it's 4 terms, so I'm probably going to have to slash it and see if it'll factor, right? Greatest common factor of the first 2 terms, x squared. What's left when you take out x squared? 2x minus 5. Middle sign, GCF of the last 2. 20. If you take out 20, what's left? That's exactly right. You know you've done it correctly because these two are the same. Okay? So the 2x minus 5 is my common factor here. Then x squared plus 20. And I still want to look and see, can I factor it any further? No, because there is no other pattern there. So I'm going to go ahead and put each piece to 0. This is my easy solve, my linear. I get 5 over 2. There's one solution. I'm looking for a total of 3 solutions. If I move the 20 over, what do I have to do now? Square root. That's exactly right. So I've got the square root plus or minus the square root of negative 20. So 2 things happening there. The I, and then splitting it up. How does it split up, by the way? There you go. 4 and 5, which is 2I root 5. there's my last key. 5 or 6, I sure can. Only if there is a square root in the bottom. So if this had been the square root of 5 over 2, then that would be square root of 5 over square root of 2. Then yes, this is where I would do, okay, times square root of 2 times square root of 2, square root of 10 over 2. But because there's no radical, you don't have to worry about that. Does it matter which one, Aiden? This one already equals 0. Should get 3 solutions here. Is there a GCF? I hear yes and I hear no. No GCF here. No GCF here. So this one is already a pattern as it sits, and whenever you look at it, I hope you're to the point where you see the 8 and the 125 and go, oh, those look like cubes. And then you say, well, that's the difference of 2 cubes. And so I set up my same change plus. Now what times itself 3 times gives you 8x cubed? 2x. What goes here? 5. That's exactly right. Now use these to write the second parentheses. Square the first. A lot of you in your classwork, you didn't square that coefficient. Make sure you square the coefficient and the variable. Multiply them together for the middle. Square the last. Now I am ready to solve. 2x minus 5 equals 0, and 4x squared plus 25 equals 0. The linear one should be a quick one for you. Doesn't take a whole lot of thought there. The quadratic, however, again, this was a cubic, so I am going to have to go through that quadratic formula. Opposite b plus or minus the square root of b squared minus 4 times a times o. Did that factor? Yeah, we do. Oh, no, never mind. For which one? Number 5. Mine says 8x cubed minus 125. Alright, so I got negative 10 plus or minus square root of 100 minus 4 times 25 is 100, but then times 6, that gives me 400. So this would be negative 300. Is that what y'all got? Negative 300, again, I'm going to come over to the side because it's a little bit easier for me. I know I have the I. What perfect square can I divide 300 by? This is an easy one. 100. Sometimes the easiest ones you forget about them. You don't even think about them. So this would be 10I root 3. And again, all of these could be divided by 2. So I could say, and don't mess with what's under the radical, negative 5 plus or minus 5I root 3 over 4. Anything else? 8. I'm going to get everything on the same side, so I'm going to move these 2 to keep my leading coefficient positive. So I have x to the 4th minus 17x squared minus 18. I have even half constant. And my leading coefficient is 1, so I can shortcut it. What multiplies to negative 18 but adds to negative 17? 18 and 1. So negative 18 and positive 1. Bless you. X squared minus 18. X squared plus 1. These are not perfect squares. I can't do anything else. This is a plus, so I can't separate that. So I'm ready to set it equal to 0. Add 18 and take the square root, but split it up. How does 18 split up? 9 and 2, that's exactly right. 9 and 2, so that is plus or minus 3 times the square root of 2. And then on the other side, I have negative 1, and whenever I square root that, I get what? That's exactly right. There's my 4 solutions, and that's what I was supposed to get. Okay. I need you to split your desk. You may have your orange sheet and a calculator if you want. I'm sorry, plus or minus I. So there are several different ways that we divide polynomials, and one we've already talked about. So if you look at number 1 and 2, we've already divided by monomials. Do you remember how we did that? You split them up. That's exactly right. So 6x to the 4th minus 15x cubed plus 3x squared. Do what? Oh, thank you. Over 3x squared. So monomial means one term, right? When it looks like this, we can just split up into separate fractions. This is only when I have the addition subtraction on the top only. If it's in the bottom, this doesn't work this way. But I can split up and then simplify each fraction individually. You guys remember this? So the first one, 6 divided by 3 is 2. And then 4 x's up top and 2 x's in the bottom leaves me with how many x's where? 2 at the top. That's exactly right. And then the next fraction, 15 divided by 3 is 5. And 3 x's up top with 2 in the bottom leaves me how many where? 1 in the top. These cancel, but it doesn't just go away. It leaves me with what? 1. Okay, so that's just kind of a review because that's a type of polynomial division. It's when we divide by a monomial. But what happens if we divide by something bigger? In other words, like a binomial, and we'll even talk about something a little bit bigger than binomial, but today we'll stick mainly with binomial. So the first thing I need you to understand is that factoring is really a form of division. Do you understand that? Does it make sense why? In other words, if I told you that 6 was the same thing as 2 times 3, 2 and 3 are both factors of 6. Agree with that? Okay. And I'm going to relate this back to polynomials in just a minute. Well, this means that I could rewrite this as 6 divided by 2 would give me the other factor here of 3. Okay, so really factoring is a form of division. So if you look, your very first, the 3 and 4 there, it says use factoring to divide the polynomials below. So what that means is if I have, let's say divide, 5 factoring. This just means to factor the big polynomial. Let's say big. So for example, w squared minus 7w plus 10. Now when it's written in a fraction like this, this just means division, right? Divided by w minus 5. So if I want to factor it by, if I want to divide it by factoring, so in other words, I want to tell what this equals. So think back to that 6 equals 2 times 3, which means 6 divided by 2 would give you 3, right? So I need to find the factors here of this top polynomial. Well, how does the top factor? Yep, but the a is a 1, so I can shortcut it, right? So how does it factor? -5 and -2. Do you agree with that? Well, since these whole factors are the same top and bottom, that leaves me with w minus 2. So this divided equals w minus 2. Does that make sense? All I did was factor and then cancel out the factors that were top and bottom there, okay? Kind of like if this was, okay, never mind. I'm going to leave it like that. Well, if this was 2 times 3 over 2 equals 3, I could cancel those 2's out, right? Anyway, let's look at number 4. 4 is written a little bit differently. It says that 4h squared minus 7h minus 2 divided by h minus 2, but it's the same concept. This is just not written as a fraction, but we can always write a division problem as a fraction. So I'm going to write it this way, 4h squared minus 7h minus 2 over h minus 2. Factor the top and see what happens. And I'm going to come off to the side to do it as you guys do it. Multiply. Why can I not shortcut this one? That's right, there's a 4 in front. So what multiplies to negative h squared but adds to negative 7h? Negative 8 and positive 1. So they have to add, look at the middle, they have to add to a negative here. So I need to make sure the bigger one's negative. So this should factor for you as h minus 2 times 4h plus 1. So I'm just going to rewrite the top of that fraction, h minus 2, because that's all factoring is writing it a different way. Instead of writing 6, we write 2 times 3. It's just writing that it still has its same value. Nothing has changed there. We just wrote it a different way. So what is 4h squared minus 7h minus 2 divided by h minus 2? 4h plus 1. Now, I'm going to show you long division today. I don't think we'll get to synthetic division today. Long division is the hardest. And it'll take me the longest to get through. Now, whenever you see this, you'll go, oh my gosh, how do you expect us to do this? It'll look so long and complicated, but it's really not as bad as what it looks. Okay? It follows, if you can do elementary long division, you can do polynomial long division. And that's what I'm going to do. I'm going to relate them side by side and show you what's going on here. So long division. Long division is kind of like the quadratic formula. It's the division method that always works no matter what, but it's long and it's messy. So if we can avoid it, we do. Your key to getting long division correct is going to be your neatness in keeping everything lined up and nice and neat. All right. I am going to say Let me actually make this. Sorry, I know y'all hate that. Let me just make it like that, 117. So if you look at number 5, I have this problem, x squared plus 3x minus 43 divided by x plus 8. Now the first thing, and this is not on here, you need to make yourself a big old note, is always check for placeholders. And I'm going to tell you exactly what that means. Look at the degree of each of your polynomials, the one that's being divided and the one you're dividing by, okay? And from that degree, you have to have every degree under it, okay? And if you don't, you got to hold its place or else your answer is going to come out wrong. So in other words, this is a degree of 2. I have 1 and I have a constant, so I'm good. This is a degree of 1 and a constant, so I'm good. An example of one that may not have it might be something like 3x to the third plus 7x minus 5. What is missing there? The power of 2, right? So what I need to do is hold the place of the power of 2. So to do that, I put a 0x squared to hold the place. This is what we call a placeholder. It has the same value, but it holds the place of anything with a power of 2 value. Does that make sense to you? Okay. That's going to be the only kind of wonky thing right now that we're going to need to look for. So look for it here and here as you set up. Most of the time you're not going to need it, but in the case that you do, you need to know that you have to add that in there, okay? All right, so let's set it up. If this is my division problem, what goes outside the little house and what goes inside the little house? The what? Well, but not always, because, but, I mean, you're right here in this one, but I'm saying, how do you know which one? It's always the one that comes before the division sign that goes inside, right? This one could be written as 117 divided by 4, okay? So same setup. So the x plus 8 goes on the outside. The x squared plus 3x minus 43 goes on the inside. Everybody with me? All right. Look at my example over to the left. I'm going to try to use colors here to color coordinate. Yep. It may be written as a fraction. This could also be written as x squared plus 3x minus 43 over x plus 8. Any of those three forms could be given to you, and you have to be able to get it in that division sign. All right, looking at this 4 into here, tell me what is the first step you do when you long divide that? You see how many times does 4 go into 11? Agreed? Everybody agreed? And where do you put that number? The top. So 4 goes into 11 2 times, and I put it right up top. All right, stop there. Come over to the polynomial. Look only at the very first term. How many times does x go into x squared? Or in other words, what do you multiply x by to get x squared? X. Do we all agree? Okay. I'm going to put it, now these are columns. This is power of 2, power of 1, and constant. So I'm going to put the x right up here, just like I did the 2. Okay. Now, go back to the blue example. What do I do with this 2? You multiply here, right? 2 times 4, and you put the 8 under here. Now I'm going to do the same thing. Take this and multiply it, but it's got to multiply to everything out here. So it's going to be x times x and x times 8. And you're going to keep your columns lined up, okay? What is x times x? Okay. What is x times 8? 8x. Okay. Back to the blue example, what do you do? Subtract. 11 minus 8 is 3. So back over here, I am going to subtract all of this, every bit of it, okay? This is a positive 8x, and I'm subtracting it. X squared minus x squared, and those should cancel out for you if you've done this correctly. 3x minus 8x, negative 5x. You see how these steps are following the exact steps of a regular long division? It's just like division on crack now. All right. Now what do you do? Go back to the problem on the left. What do you do? After you subtract, you bring down the 7. I bring down the 7. So here, I'm going to bring down the next term. Now what? I start the whole thing all over again, right? Except this time I'm looking here. What do I multiply 4 by to get 37, or as close to it as I can get? 9. And it goes up here. So same process. What do you multiply x by to get negative 5x? Negative 5. It goes up top. Multiply around, just like I do here. Negative 5 times everything outside. Negative 5 times x is, yes, and negative 5 times 8, subtract, but I'm subtracting everything. So it's negative 5x minus negative 5x, 0. Negative 43 minus negative 40, negative 3. Whoa, didn't mean to do that. Now, there's nothing I can multiply x by to get 3. There's nothing I can multiply 4 by to get 1. What do we call that number? The remainder. Now you're really going to have to think back, make your 5th grade teachers proud. What do you do with the remainder? Not put a decimal and just keep it going, but what? You make it into a fraction. That's exactly right. You say this is 29 and 1 over 4. That's exactly right. I'm going to do the exact same thing here. I'm going to say that this is x minus 5 plus, I'm going to take the remainder, negative 3, and put it over the outside, x plus 8. So this answer, when I divide these two polynomials, I get x minus 5 plus negative 3 over x plus 8. Yikes, I know. You always add the remainder over what you divided by. Yes. Let's look at number 6. I know number 6 says synthetic, but we're going to do it long division. Actually, let's go to one that has a missing. Let's do number 9. I have k to the third minus, I know the bells probably, the announcements are going to catch me, but we have enrichment now. All right, what goes outside? And first of all, what do you notice that's different about this one? I'm missing a power of 2. Good job, Cricket. So I need a placeholder, right? I need a 0 placeholder. So this is going to be k to the third plus 0k squared minus 17k plus 32. This one's going to be a step longer because I have just a little bit more there in the numerator. Which one goes outside? Outside. That's right. Yep. K plus 5. All right. So I've got k plus 5. Every time I teach this, the general consensus is it's not that hard because it relates so much to long division. It just takes so stinking long. All right. K to the third Don't forget your placeholder because everything in that column is going to be power 2, and if you don't have it, you won't have a place to put powers. All right, tell me what to do first. Look at y'all. What do I multiply k by to get k cubed? K squared, right? And so I go to the squared column. Now what? Multiply. It has to multiply to everything outside, not just one. So k squared times k. K squared times 5. Look at y'all long dividing. Subtract. What do you get? Yeah. Bring down the next one. And now there is so much repetition in here that if you do a couple, you can't help but get it because you keep doing the same thing over and over and over. What do you multiply k by to get negative 5k squared? Negative 5k, right? I need another k on there too. So I go to the k column and I write negative 5k. Now what? Don't subtract yet. Multiply around. That's exactly right. Now be careful because I'm multiplying by a negative 5k. So negative 5k times k. And negative 5k times 5. See why we took some time adding, subtracting, and multiplying polynomials there for a while? You get to do it all in the division problem. All right, now subtract negative 5k squared minus negative 5k squared. Right? And it should cancel for us if we've done it right. Negative 17k minus negative 25k. Right? Signs will throw you off on this. That's the big, if you're neatness and signs, that's where you're going to mess up. So be very, very careful. Drop down the next one. Same process one more time. What do you multiply k by to get 8k? 8. It goes in the constant column. It's positive. Multiply it around. 8 times k is? 8 times 5 is? Remember, I'm subtracting everything here. So 32 minus 40 is negative 8. There's nothing else there I can do, right? Everybody always says, how do you know when to stop? When you can't multiply this by anything and get this, you stop, okay? That's now my remainder. So I'm going to say plus negative 8 over k plus 5. Now, Brooklyn, you asked about how do you know it's plus and it's always plus. Now, if there's just one thing in the fraction up top and you want to make it subtraction, you can, but you don't have to. You were following along but doing the wrong one. All right, so this equals k squared minus 5k plus 8. Let me ask you this. Is k plus 5 a factor of that polynomial? What's it mean to be a factor? What's the basic definition of a factor? Not what we've been doing, but go all the way back to 5th grade whenever you learned about factors. What does it mean to be a factor? Okay, give it to me in division terms. You can divide by with no remainder, right? It goes in evenly. Is k plus 5 a factor of that polynomial? No. Why? I got a remainder. Great work, right? If there's a remainder, it's not a factor. That is, by definition, not a factor, and that's why we couldn't factor it to solve. Okay, So what I want you to do is just to finish through 10. So that gives you, don't do synthetic, do long division on that one. And we're going to talk about synthetic tomorrow. Just the first page. Tomorrow we'll do the second page. I'll teach you synthetic tomorrow, which is a shortcut, but only works sometimes, but it's quite convenient.